Intermediate Algebra, Section 7.7, two special triangles. When both legs of a right triangle are the same size as shown, we call the triangle an isosceles right triangle or a 45-45 90-degree triangle. The length of the hypotenuse in an isosceles triangle or the 45-45 90-degree triangle is the length of the leg x here, each one of these is x because of its isosceles, times the square root of 2. And this is derived from the Pythagorean theorem. So the length of the hypotenuse of an isosceles right triangle is x times the square root of 2. A second special triangle is known as a 30, 60, 90-degree triangle, so named because of the measures of its angles. If we let the shorter leg, and the shorter leg is always the side of the right triangle opposite the smallest angle, so this is 30 degrees, the opposite leg is equal, we'll call it x, we can determine the length of the longer leg, which would be the other side of the 90-degree angle, by taking the length of the shorter leg and multiplying it by the square root of 3. The hypotenuse in this special 30, 60, 90 degrees turns out to be twice or 2 times as long as the shorter leg. So again, here in the diagram, our smallest angle in this 30, 60, 90 degree angle, or right triangle, is here. The shortest leg is x. Because it's x, and the relationship derived from using Pythagorean theorem, the other leg length is that measurement of the shorter leg times square root of 3, and the hypotenuse is double the length of the longer leg. You may want to remember these because they're going to be helpful when studying trigonometry as far as the relationships of the side lengths in an isosceles right and also a 30, 60, 90 degree. Let's look at a couple of examples. And in this first one, we're given this right triangle with a 60-degree angle here, which would mean if this is 90, this would be our smaller angle. And to start this problem, to find the lengths of x and y, we're going to identify the shorter leg. And this is the shortest leg because it's opposite the 60-degree angle. And in that relationship that we just went through, it tells us that the hypotenuse is equal to double or 2 times the shorter leg length. Well, if we plug in what we have, we're given that the hypotenuse is 4, 2 is our factor with the relationships of these lengths. In the problem, we're given y for our unknown value for the shorter leg length, and solving this for y, we end up with y has a value of 2. Once we know the length of the shortest leg, we then can solve for the other leg length, which has a relationship of the longer leg is equal to the shorter leg length times the square root of 3. Well, the longer leg is x. The shorter leg we just solved and found it had a value of 2, and we'll times that by 3. There's nothing to solve. We have the longer leg length then. The value of x is 2 times the square root of 3, and y, the length of our shorter leg, had a value of 2. In this next example, we're given a right triangle that has a 45-degree angle, using the fact that the sum of the angles in a triangle equals 180, and we have a 90 and a 45, this would mean this is also 45 degrees, making this an isosceles right triangle. And the sides, in this case the legs, opposite those equal base angles are equal to one another. So we have a 45, 45, 90-degree triangle, and in such an isosceles right triangle, the relationship between the leg length and the hypotenuse is such that the hypotenuse is equal to the leg length, whatever that happens to be, times the square root of 2. Plugging in what we know, we are given the hypotenuse, we're looking for a leg length, x and y are equal to one another, so it doesn't matter which variable we choose. I'm going to let the leg length equal x, and we multiply it by the square root of 2 to give us the hypotenuse. To solve for the missing leg length, we'll divide both sides by the square root of 2, and that's giving us the length of one of the legs is 8 over the square root of 2. Because of the fact that this is isosceles, x also is the same value that y would have, and if we leave this in exact form, we would answer 8 over the square root of 2.